Now let's do problem 6. So here's problem 6, two parts. The first part is to compute an inverse. So if you're watching this before class on Tuesday, we have not yet inverted a function in class, but on Tuesday we should start doing that. Okay, so here's the function, and just by the way, what does that look like? You know, that's an upper semicircle with radius 4. You should know that. And if you don't know why that is or what I'm talking about, ask me about it in class before the exam. Alright, and there's the diagonal. So notice that this thing is a reflection of itself on this in the positive quadrant here. So in quadrant 1 or whatever. So we're looking at the domain between 0 and 4. So here's the domain between 0 and 4. And on this domain, this function is its own inverse. So if you reason that out and conclude that it's its own inverse, you can just write down immediately that the inverse function is f of x. Okay, so that would be a right answer. But let's go through and compute why it's true. So how do you compute the inverse? First you set y is equal to 16 minus x squared. And now all we have to do is solve for x. So we want to solve for x. That's a way of like undoing the function. Alright, so I need to get rid of the radical, so y squared is equal to 16 minus x squared. Now let's move the 16 over, so y squared minus 16 is equal to negative x squared. And now let's multiply through by negative 1, and so that's going to put just x squared over here, and it's the same thing as switching the order of that subtraction around. So let's write it as 16 minus y squared. Okay, and now x is equal to, take the square root of both sides, plus or minus the square root of 16 minus y squared is equal to x. But look, we're not considering the negative solution because we're only looking at this domain from 0 to 4. So the domain 0 to 4. Alright, so that means that we ignore the negative solution. We're not considering negative x's. So we just have that x is equal to the square root of 16 minus y squared. And you know, finally, the final step in computing the inverse is to just swap x and y after you've solved for x in terms of y. So if I swap x and y in this equation here, what do I get? I get the square root of 16 minus x squared, which is f. So we've proved it. Okay, so this function is its own inverse and we computed it honestly. That's the answer to part A. Alright, so let's give a third and final proof here that this thing is actually its own inverse. So what do we want to do? We want to compose it both ways, right? You have to compose a function with its purported inverse both ways. That means the function first, then the purported inverse, and then the inverse, and then the function. And if both times it comes out to be x, so it just sends x to x, we call that the identity function. So when you compose two functions both ways and you get the identity function both times, that's the same thing as two functions being inverses. So let's compose this thing with itself and show that it kills itself, that x comes out when we compose it with itself. Okay, so you know, we want to do f composed with its inverse, the same thing as f composed with f. And so you can see here's the function which is f and its inverse. So let's compose those things. So that means I'm just going to stick the whole expression in for x itself. I've got 16 minus, now I've got the square root of 16 minus x squared squared. Okay, right? That's what happens when I stick the whole expression in for x. And so let's see what happens here. I've got the square root of 16 minus, now look, this radical and this square are going to kill each other, right? And I'm just going to have 16 minus x here. And I have to be careful about the negative signs. Okay, alright. So this is equal to the square root of 16 minus 16 plus x squared. So distributing that negative sign in here, that's what you get. And clearly, 16 minus 16 is 0, so I've got the square root of x squared. Alright, And this is just another way of saying the absolute value of x. Okay, but again, I have to appeal to the fact that we're just looking at this domain from 0 to 4, so x is positive that whole time, right? So on that domain, so on 0 to 4, the square root of x, or sorry, the absolute value of x is just x because it's already positive. And so we've shown that on the domain 0 to 4, f composed with f inverse of x is equal to x. Right? So actually the absolute value came out, but on this domain it's the same thing as x. Alright, and so since this thing is its own inverse, composing it the other way is going to give you the same thing. So this is equal to f minus 1 composed with f of x, because f minus 1 and f are the same. Okay, and so we're done. We've verified that these things are inverses of each other. And so that finishes part B and the exam.